All right, so today we're going deep on Rudolf Carnap.
Carnap, yeah, really important guy. 20th century philosophy. Can't get around him.
Right. I mean, you think logical positivism, there he is, but it's more than that, right?
Way more. Philosophy of science, how we make meaning, uh, even inductive logic, figuring out the best guesses. It's all over the place.
And people are realizing that now. Like, it's relevant again to so much of what philosophy's tackling.
Big time. It's like he was ahead of the game in a way. What strikes me is how different his whole approach was. Most philosophers, they're trying to find some ultimate truth. Big arguments, abstract stuff.
Yeah, the classic philosopher, like deep in thought about the universe and all that.
Exactly. But Carnap, he was different. He saw a lot of these philosophical problems as like coming from how we use language every day.
Which, let's be honest, can be pretty messy. We're not exactly logical robots.
Right. So instead of just arguing about abstract concepts, he thought we should focus on designing better ones.
So he's like a conceptual architect.
Yeah, that's a good way to put it. Conceptual engineering, that's the term people use.
Building better tools for thinking.
Exactly. And for him, philosophy wasn't about figuring out how things are in some deep metaphysical way, but about how we want to think about them. Especially for science. You need clear, precise language to make progress.
So there's a choice involved then. It's not like there's one right way to think about things.
That's the idea. He called it voluntarism. We get to choose the best concepts for the job, just like you pick the right software for a task.
That's pretty different from how people usually think about philosophy. And this wasn't just like tinkering with definitions, right? He wanted to apply this idea on a much larger scale.
Absolutely. It wasn't just individual concepts, but whole frameworks of language. Like, imagine building a whole new logical system, almost like a mini language, with its own rules and definitions.
So it's not just the words, but how they fit together, the rules of the game.
Exactly. And these frameworks had a meta-language, too, which is basically a language to talk about that first language.
Yeah.
To define what truth means in that system, or what makes a statement analytic. Pretty meta, right?
Meta, for sure. And these systems weren't just static either. He even wanted to incorporate inductive logic, how we reason from observations to general conclusions. Like, how do we move from, I saw a few white swans, to all swans are white, even though that turned out to be wrong.
That's right, and that's a really ambitious part of his project. He wanted to formalize that whole process to figure out, like, degrees of confirmation based on the evidence.
So it's about the strength of our beliefs, how confident we are in our conclusions, and how that's tied to the evidence.
Exactly. He wanted to make it all rigorous, all tied to logic and probability.
So one of his early attempts at this kind of grand system was his book, The Aufbau.
The Aufbau, yeah, the logical construction of the world. Super ambitious project. He basically tried to build up our entire understanding of the world from scratch, starting with just our basic experiences, like what we see, hear, feel, that kind of thing.
Kind of like building a giant Lego model of the universe brick by brick.
Yeah, kind of. The idea was that all our knowledge, all our scientific concepts, could be traced back to those basic building blocks of experience. He called this approach phenomenalism.
It sounds simple on the surface, but I bet it got complicated fast.
Oh, it did. Especially when you start thinking about things like theoretical concepts. Like electrons, you can't directly observe those, right? Or things like fragility. It's not something you see directly, it's a potential. And probabilities, those are tough too, because it's about likelihood, not certainty.
So, like trying to build that Lego universe, but with only half the instructions and some weird bendy pieces.
Right, and Carnap himself realized this. The Aufbau was really important, but he knew it had limitations. You can't just reduce everything to simple observations, especially in science.
Which brings us to something that always comes up with Carnap. His view on metaphysics. He wasn't a fan, right?
Yeah, famously skeptical. And that might seem odd, given all this talk about choosing frameworks and building systems. Why would he be against metaphysics if it's all about choosing how we think?
Yeah, that's what I'm wondering. If we have a choice, why not choose to be metaphysical?
Well, it comes back to this engineering mindset he had. For him, language was a tool, a way to move beyond the limitations of everyday language. He thought our ordinary way of talking is just too messy, too rooted in practical concerns, not precise enough for real knowledge.
So it's like he's saying, look, we evolved language to survive, not to do physics or write philosophy papers.
Yeah, something like that. And for him, better languages were those that aligned with the values of the Enlightenment. Objectivity, scientific rigor, testability, that kind of thing. He wanted to move away from just accepting tradition or what authorities told us.
So metaphysics was like a distraction from this project, like a bunch of fancy words that don't really get us anywhere.
Yeah, he thought it was a failed art form, masquerading as knowledge. You know, in science, you can test your claims. In logic, you have clear rules. But metaphysics, it's all just endless debates with no clear criteria for who's right. Like arguing about whether a painting is beautiful, it's subjective.
But I've always wondered, even if he thought it was pointless, did he ever actually define what metaphysics is? Like, how do you separate a metaphysical claim from a scientific one?
That's the thing. It's harder than it sounds. He tried for years to come up with a clear definition, but it never really worked out.
So even the guy who wanted to get rid of metaphysics couldn't quite pin it down.
Right. And later in his career, he actually softened a bit on it. He started to see some past metaphysicians like Aristotle or Kant as maybe doing early, less formal versions of what he was trying to do.
So like proto-framework builders.
Yeah, kind of. He still thought most of it was misguided, but he saw some historical value there.
So we see this arc in his thinking, from the Aufbau, where he wants one system for everything, to this more tolerant view where there can be multiple frameworks. It really makes you think about how we choose our tools for understanding the world.
Absolutely. And it all goes back to this core idea, distinguishing meaningful statements from empty verbiage. That was his big project from his early days with the Vienna Circle, right through to his later work.
And that early work was heavily influenced by Wittgenstein, right? I know there was this idea of a molecular language where you couldn't make these really broad, sweeping statements.
Yeah, the idea was that our language should be grounded in more basic, observable stuff. But that ran into problems when you tried to apply it to science. Scientists are always making these big, universal claims. All electrons have negative charge. The universe is expanding.
And that's where verificationism comes in, right? That a statement is only meaningful if you can verify it through observation.
Well, that's the popular version. But it's a bit of a caricature. Carnap was more sophisticated than that. Even in the Aufbau, he knew you couldn't just reduce everything to simple observations. And pretty early on, he recognized that you can't definitively verify those big scientific claims.
Because you can't observe every single electron or every corner of a universe.
Right. You can only gather evidence, and that evidence can support a theory to a certain degree or maybe even disprove it, but you can never be absolutely certain. And this was before Karl Popper made falsification famous, so Carnap was really ahead of the curve there.
So it's more about confirmation and disconfirmation rather than strict verification?
Exactly. And that led him to this really important idea, the principle of tolerance, which he laid out in his book, Logical Syntax of Language.
And this was a big shift, right? Away from the idea of one correct language.
Huge shift. The principle of tolerance basically says that when it comes to logic and formal languages, there's no one right answer. You're free to choose whatever system works best for your purposes.
So it's not about finding the true language, but about designing the most useful one.
Right. It's very pragmatic, very much in line with that engineering spirit.
And this led him to focus more on inductive logic, right? Figuring out how we make those good guesses, how we move from evidence to conclusions, even when those conclusions are probabilistic.
Exactly. After the mid-1930s, that became his main focus, and he made this important distinction between two kinds of probability. There's probability as frequency, like how often you get heads when you flip a coin. That's something you can measure. It's in the world. But there's also epistemic probability, which is about our degree of belief. How certain are we that something is true, given the evidence we have?
So one's about what actually happens, and the other's about what we think will happen.
Precisely. And it's that second kind, epistemic probability, that he was really interested in. He wanted to develop a formal system to quantify it, to figure out exactly how much a piece of evidence should change our confidence in a theory.
Like putting numbers to our beliefs.
Yeah, that was the goal. And that work, though maybe not as famous as some of his other stuff, was actually very influential. It laid the groundwork for a lot of modern statistics and how we think about evidence today.
Another aspect of his thinking that I find really interesting is his structuralism. This idea that what matters isn't the stuff itself, but the relationships between things, the patterns. And that seems to have been a theme throughout his work.
Yeah, it's a deep idea that shows up everywhere. He thought mathematics wasn't really about numbers, but about abstract structures and how they relate. And in science, he argued that we shouldn't be so focused on the essence of things, but on building accurate models of how they behave, how they relate to each other.
So it's like instead of asking, what is an electron,
Yeah.
we should ask, how do electrons interact with other things?
Exactly. He thought that was a more productive way to do science, and it fit with his emphasis on objectivity. We can all agree on the structure of something, even if we disagree about what it's made of.
And this focus on structure also connects to his work on logic, right? It's about the relationships between statements, how they logically follow from each other.
Totally. He was way ahead of his time in thinking about this stuff. Like Alfred Tarski, a really important logician, had similar ideas about logical consequence. And even today, there's this whole field of mathematical structuralism that's basically building on what Carnap started.
So even though he wasn't always right, he was definitely asking the right questions, the ones that are still relevant today.
For sure. And one last thing we should touch on is his views on values, on ethics. He's often called an ethical non-cognitivist, which basically means he didn't think he could be right or wrong about moral statements.
So like murder is wrong isn't true or false in the same way that the earth is round is.
Right. But here's the interesting thing. Recent scholarship has shown that he might have had a more complex view, even a quasi-Kantian one, where he thought ethical reasoning was actually a different kind of reasoning altogether, but still really important.
So he might have had a way to fit ethics into his system after all.
Possibly. And that just shows how much there still is to learn from Carnap. Even decades later, people are still finding new insights in his work.
So to wrap up, I think it's safe to say that Carnap was a huge figure. He wanted to separate sense from nonsense. He thought we should design better ways to think. And he really pushed the boundaries of logic and language.
Absolutely. And I think the big question he leaves us with is this. How do the choices we make about language and frameworks shape not only how we understand the world, but also what questions we can even ask?
Because if you can't even ask the question, you're not going to find the answer.
Exactly. And that's relevant to so much, from science to politics to our everyday lives. Carnap's work really makes you think. What are the right tools for thinking, and how can we build better ones?
Great question to leave our listeners with. Thanks for joining us on this deep dive into Carnap.
My pleasure.
And until next time, keep thinking.
Keep thinking.